Hello everybody. In the previous videos we have studied about similar triangles. We also studied the criteria for similar triangles. And in this lesson now we will study about the areas of similar triangles. So welcome to the lesson. We know that the similar triangles, in similar triangles, the ratio of the corresponding sides is equal. Suppose if triangle ABC is similar to triangle PQR, then AB over PQ is equal to BC over QR equal to AC over PR. We know that. But what about the areas of similar triangles? Are they related to the ratio of the corresponding sides? Let us see what the theorem says. The theorem says the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. What does it mean? It means that the ratio of the areas of these two triangles is equal to the square of their corresponding sides. What are the corresponding sides? AB over PQ. Square that. So, in other words, the theorem is telling that the area of ABC over PQR is equal to the ratio of the corresponding sides, their squares, AB over PQ, the whole square, equal to BC over QR, the whole square, equal to CA over RP, the whole square. Can we prove this? Of course we can. And let us see how we go about proving this theorem. So let's prove the theorem. Now we are given that triangle ABC is similar to triangle PQR. And we are supposed to prove that the area of ABC over the area of PQR is equal to the square of the ratio of their corresponding sides, is equal to AB over PQ, the whole square, equal to BC over QR, the whole square, equal to CA over RP, the whole square. Now, in order to prove that, let us draw a perpendicular line AM to BC and PN, a perpendicular line to QR. So, let's look at the triangle ABC. What is the area of the triangle ABC? It will be half base, which is BC, times height, which is AM. So the area of triangle ABC is going to be half BC times AN. Now look at triangle PQR. What will be the area of triangle PQR? It is half base QR times height PN. So area of triangle PQR is going to be half QR times PN. Now what will be the ratio of these two, area of ABC over area of PQR? It will just be the two, half BC times AM over half QR times PN. Half cancels, you are left with BC over QR times AM over PN. Let's label this as equation 1. Now let us look at triangles ABM, this triangle, and PQN, this triangle. So what do you observe? Can I say that angle B is equal to angle Q? Why? Why do I say that? Because triangle ABC is similar to triangle PQR. It's given in the question. Because triangle ABC is similar to triangle PQR. So angle B is equal to angle Q. Can I say angle M is equal to angle N? M is equal to angle N, and each is 90 degrees. Why do I say that? because they are perpendicular lines drawn and they each equal to 90 degrees. So angle B is equal to angle Q, angle M is equal to angle N. Two angles of the triangles are similar. So can I say triangle ABM is similar to triangle PQN? Which criteria? Angle similarity criterion. Now if triangle ABM is similar to triangle PQN, their ratio of their corresponding sides will be equal. In other words, AM over PN will be equal to AB over PQ. So AM over PM is going to be equal to AB over PQ. Let's label that as equation 2. We also know that it's given in the question that triangle ABC and PQR are similar triangles. Remember that? So if they are similar, then the ratio of their corresponding sides are also similar. So AB over PQ is equal to BC over QR equal to CA over RP. Let's label this as equation 3. So now we have 3 equations and let us see how we can bring them together. So these are the 3 equations that we have. Equation 1, equation 2 and equation 3. So now observe over here, area of ABC over area of PQR. BC over QR, BC over QR, is it same as AB over PQ? So from 1 and 3, can I say area of ABC over area of PQR is AB over PQ, because BC over QR is same as AB over PQ, times AM over PN. This we got it from 1 and 3. Now what is AM over PN? From 2, observe, AM over PN. Can I say that is also equal to AB over PQ? So instead of AM over PN, can I write AB over PQ? I can. So now can I say it is AB over PQ times AB over PQ? Because we replaced AM over PN from 2 by AB over PQ. So this now will become AB over PQ the whole squared. So from now, area of triangle ABC over area of triangle PQR is nothing but AB over PQ the whole squared, which is nothing but BC over QR the whole squared, which is nothing but CA over RP the whole squared. So the ratio of the areas of similar triangles is equal to the square of the ratios of their corresponding sides, and thus we have proved the theorem. Great step-by-step proving. Let's try this problem based upon the theorem. Let triangle ABC is similar to triangle DEF and their areas be respectively 64 centimeter squared and 121 centimeter squared. That means the area of triangle ABC is 64 centimeter squared and area of triangle DEF is 121 centimeter squared. If EF is 15.4 centimeters, find BC. So we already know according to the theorem that the ratio of the areas will be equal to the square of the ratio of the corresponding sides. So 64, the ratio of the areas, 64 over 121 is going to be equal to the square of the ratios of the corresponding sides, BC, which is x, over EF, which is 15.4, the whole square. Now we can take square roots on both sides. If we take square roots on both sides, what happens? Square and square root cancels, and then we have x over 15.4 is equal to square root of 64 is 8 over square root of 121 is 11. From here we can just cross multiply. So, x is going to be equal to 8 times 15.4 over 11. So, x is going to be equal to 11.2. So, x is going to be equal to 11.2 centimeters. But what is x? It is BC. So, BC is 11.2 centimeters. That is how we apply the theorem in solving the problems. Let's try this. The line segment XY is parallel to AC of triangle ABC, and it divides the triangle into two parts of equal areas. Find the ratio of AX to AB, AX to AB. Okay, so we know that XY is parallel to AC. How do we know that? Because it's given. Then, if XY is parallel to AC, angle BXY, this angle, will this angle be equal to angle A? This angle and this angle, will they be equal? Yes. Why? Because they are corresponding angles. The same thing, angle BYX, this angle, will this angle be equal to angle C? Yes, because they are corresponding angles, because XY is parallel to AC. So, angle BXY is going to be equal to angle A, and angle BYX is going to be equal to angle C. They are corresponding angles. So, can I say then that the triangle ABC is similar to triangle XBY according to AA similarity criteria? Because if two angles of the triangle are equal to two angles of the other triangle, then according to AA criterion, the two triangles are similar. So, we have shown now that the two triangles are similar. So, if the two triangles are similar, what will be the ratio of the areas of those triangles? The ratio of the area of the triangle ABC over the area of triangle XBY, it will be AB over XB the whole square, because the ratio of the areas is equal to the square of the ratio of the corresponding sides. We know that. But the question says that the line XY divides the triangle into two equal areas. So, can I say that the area of triangle ABC is 2 times the area of the triangle XBY? Because that's already given in the question. It says that the line divides it into two equal areas. So, if that is the case, area of ABC is equal to 2 times the area of XBY. So, can I then write the ratio of the triangle ABC over XBY? I am bringing area of XBY over here. If I bring this down, it's going to be 2 over 1. So, let us label that as equation 2. So, now we have equation 1, equation 2. So, equation 1, area of ABC over XBY is equal to AB over XB the whole square. So, instead of this, can I replace it with AB over XB the whole square equal to 2 over 1. So, I can write the ratio of the areas is nothing but the square of the ratio of the corresponding sides. So, if this is replaced with this, it will become AB over XB the whole squared is equal to 2 over 1. Take square roots on both sides. So, what happens? AB over XB will be square root 2 over 1. So, we know that AB over XB is root 2 over 1. Can I just flip the fraction? Instead of writing AB over XB, let me write it as XB over AB. Then it will become 1 over root 2. So, the fraction, if we flip, is going to be this. Now, observe very carefully. XB can I say XB is equal to AB minus AX? XB is AB minus AX. So, I can write XB as AB minus AX. So, it's going to be the top one XB will become AB minus AX instead of XB over AB is equal to 1 over root 2. Now, if I just split the AB to both AB and AX, what will I get? I will get 1 minus AX over AB is equal to 1 over root 2. Now, if I move minus AX over AB on the other side and 1 over root 2 on this side, what will I get? I get 1 minus 1 over root 2 is equal to AX over AB. So, if we simplify this, we get AX over AB is equal to, taking the LCM and all that, so root 2 minus 1 over root 2. And in your lower grades, you have learned how to rationalize the denominator. So, rationalizing, multiplying and dividing by root 2 over root 2, we will get AX over AB will be equal to 2 minus root 2 over 2. So, AX over AB is going to be 2 minus root 2 over 2. So, we have shown what is AX over AB by applying the theorem 6.6, the ratio of the areas of similar triangles. Great going. I really appreciate your effort that you are putting in to understand the concepts that are presented in the lesson. Keep trying, keep working. The more number of problems you work, the more proficient you become. So, take up more problems, similar type of problems based on the theorem, and keep working consistently, persistently and regularly, because your results will be in proportion to the efforts that you put. So, keep watching the videos. Please share and subscribe with your friends and colleagues. Thank you for watching this.